इसमें गॉट इट आ रहा है, गॉट इट को कवर कर दो। हेलो एवरीवन, हाउ आर यू? माई सेल्फ डॉक्टर पंकज कुमार शर्मा। सभी को मेरा प्रेम भरा नमस्कार। टुडे माय टॉपिक इज लेजर एंड इट्स एप्लीकेशंस। माई सेल्फ डॉक्टर पंकज कुमार शर्मा, एसोसिएट प्रोफेसर ऑफ फिजिक्स, डिपार्टमेंट ऑफ अप्लाइड साइंस एंड ह्यूमैनिटीज, IIMT College of Engineering, Greater Noida. The laser and its applications is very important topic nowadays because laser have a lot of applications in various fields. So before starting the laser, I want to share the views why the laser and what is the laser and what will be the future in the absence of the laser and what is the present scenario and what are the applications of the lasers in the various fields. So let us take a start. Yes, as you see, laser is very danger. So you cannot handle it by the open eye. If the laser beam strike on the eyes of any human body, then they can destroy the skin or the eye. So it is very, very danger. So you hold it very, very safety and very carefully. Now, you see, the laser light is the very highly intense beam in the practical purposes. So the red light or the wavelength color of the red light is very essential part for the intensity of the laser light. The laser light is very important due to the various regions. This is the outline my talk. In this lecture, we will discuss about the introduction about the laser, properties of the laser, basic concept of laser, principle of laser, and difference between spontaneous and stimulated emission. Then various types of the laser and then application of the laser. So the whole content cover in this topic, introduction to laser. So we will elaborate this point to point one by one. If you see laser, as you see, laser stands for light amplification stimulated emission of radiation. The light amplification by stimulated emission of radiation have the various concepts of the physics. Suppose what is the light, what to understand by the amplification, and what is the stimulated emission and radiation. Light is nothing but it is coming in the form of the radiation in the group of the photons. You know very well about the Planck's quantum theory. If the signal have the intensity high, then it's called as the signal is amplified. The stimulated is also known as induced. So induced and stimulated are the same thing by the inspiration of some logical phenomena. And the radiation, the light coming from the sun on the surface of the earth in the form of radiation. So light amplification stimulated of emission is the full form of the laser. As you see, C.H. Towns in 1994 and T.H. Mammon in 1960 shared the Nobel Prize in Physics 1964. So laser discovered by the Professor T.H. Mammon and Towns in 94 in Nobel Prize shared in 1964. This is the discovery of the first laser in the form of the ruby laser. So T.H. Mammon discovered ruby laser, which is known as 3-level laser in the 1960. But we are going to the history of the laser. You see, the credit goes to the Professor Einstein about this idea of the stimulated emission of the radiation. The laser is the based upon the maser. What is the maser? Maser is the microwave amplification stimulated emission of the radiation. So let us see the further part of the laser in terms of the history of the laser. You see, These are the scientists invented in 1958 by Charles Townes, Nobel Prize in Physics in 1964, and Arthur Shallow and the Bell Laboratories. So Bell Laboratories scientists Charles Townes and Arthur Shallow shared the Nobel Prize in Physics 1960 for the concept of the laser. So Bell Laboratory goes to the credit for the Nobel Prize winner scientist in the form of the C. Townes and the Arthur Shallow, was based upon Einstein's idea of the particle wave duality of the light more than 30 years earlier. So the concept of the laser or maser, already given by the Einstein 30 years before on the concept of particle wave duality. The term originally is known as maser, M for microwave, and later on M is replaced by the L, microwave replaced by the simple light. So maser is converted into the form of the light amplification stimulated emission of radiation, and which is known as in the form of the laser. So laser works just like that microwave, and the microwave term replaced by the light. This is the history of the laser. This is the first patent in the 1958. Maser stands for microwave amplification by stimulated emission of radiation, and the maser is similar to the laser but produced only microwaves. Now, concept is that why the laser is required when we have the term maser, because the practical purpose is laser is more useful over the maser. So microwave is substituted by the light, and the microwave amplification by stimulated emission have the another form of laser light amplification stimulated emission of radiation. The reason is that laser is more powerful and more precious and more vital role in the field of the application in comparison to the maser. So maser is the basic part, and the advanced part is known as laser. So first patent, already discussed in the 1958. This is the first part. If you go about the history of the laser, in the April 1959, Gold and TRG apply for laser-related patents stemming from Gold's ideas. In the March 22, 1960, Towns and Shallow under Bell Labs are granted US patent number 2929922 for the optical maser, now called a laser. With their application denied, Gold and TRG launch what would become a 30-year patent dispute related to laser invention. Finally, in the 1961, lasers begin appearing on the commercial market through companies such as Trion Instrument, Perkin-Elmer, and Spectra Physics. So it is the great discovery. What is the laser? As you know, light amplification by stimulated emission of the radiation. So laser is a device which produces a coherent beam of optical radiation by stimulating electronic, ionic, or molecular transitions to higher energy levels. When they return to lower energy levels by stimulated emission, then they emit the energy. So laser is a device which works on the principle of the stimulated emission. Laser works in the principle of the stimulated emission. Why not spontaneous emission? There are various basic concepts we will discuss point to point. First of all, we have to know about that the emission is quite impossible without the terminology of the absorption. So absorption is the must before going to the emission. So what are the properties of the laser? Laser has very properties. Very important properties is the monochromatic, coherent, directionality, and high intensity. If you know about the monochromaticity, monochromatic means mono means single and chromatic means color. Laser has the single color, single wavelength. So single wavelength has the more useful in the term of the monochromatic wavelength. So single color, single wavelength is known as monochromatic. And we are talking about the coherent. Then coherent are the two types of the coherent. One is known as spatial and other is known as temporal. The temporal is the time dependent and space dependent. So perfectly coherent means the light beam which is spatially coherent as well as the time means temporal coherent. The coherent which have both type of the condition, temporal as well as spatial, known as perfect coherent. And directionality, due to the unidirectional, a very target beam which is very strong and concentrated, and unidirectional gives the very important property of the laser is the high intensity. So the most important properties of laser are monochromatic, coherent, directional means unidirectional, and high intensity. If we see about the ordinary light and the laser light. Now question is that how the ordinary light is differ from the laser light. You see the electric bulb. Bulb has the different type of the multi-dimensional and multi wavelength, and laser has produced only one direction. So this is the very important part. The incandescent light have the many wavelength, multidirectional and incoherent. If you see about the laser, laser is the monochromatic, and unidirectional means only single direction, and the coherent. So these are the basic difference between the ordinary light and the laser light. You know, the comparatively study, ordinary light has many wavelength, while laser has the monochromatic. This is the multi-directional, it is the unidirectional, it is the incoherent, and it is the coherent. And laser has the sufficient property of the coherent, it should be perfectly coherent. So in coherent condition, multi-directional condition, many wavelengths are quite different from the laser. So the ordinary light has the some properties and laser has some different properties. So this is the basic difference between the ordinary light and the laser light. Due to the high intensity, the application of laser is used in the form of the laser communication or the long distance communication. If you see about the coherence, this is the very important, very interesting picture about the coherence. It is the incoherent light waves. This is the coherent light waves. If you see about the crest and trough, if you see in the coherent light of the crest and trough, so you see, or the crest and trough are in the same position. These are the same position, but they are in the zigzag position. They may be or may not be. So incoherent light have no use in the form of the coherence, and coherence light is very useful for producing the laser light waves. So these coherent lights are very useful, and this is the basic difference between two pictures, incoherent light waves and coherent light waves. If you see at the temporal coherence, when a beam of the light travel into the fiber, the coherence length L naught is equal to lambda square upon delta lambda is equal to CT naught. What is the delta lambda? Delta lambda is the difference in the wavelength, and lambda square is the square of the wavelength. This is the beam of the light. This is the incident, and at the outgoing parts, the picture shows about the temporal coherence. If you see about the L should be smaller than lambda D upon A. Well, D is the distance between the source and the screen, and A is the aerial aperture, and lambda is the wavelength of the light coming. The basic concepts for a laser is the absorption, spontaneous emission, stimulated emission, and population inversion. If you see about the absorption, spontaneous emission, stimulated emission, and population inversion, these are the basic concepts of the laser, or the backbone of the laser. The emission takes place in the form of the spontaneous stimulated emission, but it is quite different without the concept of the absorption. So emission is not possible without the absorption. So first of all, we will discuss about the absorption, and then spontaneous emission and stimulated emission, and then population inversion. The question we will discuss in this part, stimulated emission is why important in the laser action and why not spontaneous emission, or in the other words, laser works on the principle of stimulated emission of radiation, why not spontaneous emission? So it is very interesting phenomena. So first of all, we will discuss about the absorption. Before going to the absorption, you know, the electron interacted with the photon. The interaction of the radiation with the matter is known as electron photon interaction. This is the atom which lies in the ground state, and the photon coming on the light waves or the environment, the light coming in the form of the radiation. The photon interacted to the atom, and atom get excited and goes upward to the energy level. This phenomena is known as absorption. Without interaction of the atom and photon, it is quite impossible to get the energize the atom, and the electron jumps into the higher energy orbit. This the 0 is the ground energy level, and 1 is the excited energy level. So there are two energy levels. One is known as ground state energy level, and upper is known as upper energy level, or the simply excited energy level. You keep in mind the photon of the required wavelength is that the frequency must be the matching with the gap. This is known as energy gap. If there is the energy E1, and this is the E2, then the difference E2 minus E1 is equal to H nu is equal to C by lambda. So this is the nu is matching or nearby equal to the photon. Otherwise, photon could not be absorbed by the atom, and the absorption process is not takes place. So for the absorption process, the photon should be the sufficient frequency which is equal to the gap between the energy level upper and lower in the form of ground state and upper energy state. So this is the absorption process. When the photon interacted with this electron or the atom becomes excited and goes to the upper energy level. This upper energy level is known as excited energy state, while lower energy state is known as ground energy state. So the transition of the atom from lower energy state to upper energy state is known as absorption. If you see about the spontaneous emission, in the form of spontaneous emission, the excited atom remains in the upper energy orbit up to the 10 to the power minus 8 seconds only. After passing this time, the atom goes to the de-excitation process with releasing a photon. This releasing a photon is known as de-excitation process or the spontaneous emission. So in the form of the spontaneous emission, the photon of the appropriate frequency release. So the frequency release photon is known as incoherent because the de-excitation process is not constant with respect to the time, and the emission of this photon is not fixed with the time, so it behaves just like the incoherent. So incoherent condition is not useful in our laser action, so laser could not work on the principle of spontaneous emission. Now we will see the next phenomena about the stimulated emission. This stimulated emission, during the de-excitation process, one additional photon comes in association with the absorbed photon, and the pair of the photon in the same phase in the same direction is released and produce the coherent condition. Means the release of the pair of the photon is fixed with respect to time, so the condition of the coherent fulfilled. So this is very important phenomena for the laser. So laser works on the principle of stimulated emission of radiation. So if you see about the absorption phenomena, this is the one state, two state, E1 and E2, the energy gap E2 minus E1, and this photon after absorbed by the atom and excited atom goes to the upper energy level, and this phenomena is known as absorption. Energy is absorbed by an atom, the electrons are excited into the vacant energy cell. In the spontaneous emission, H nu is equal to E2 minus E1. This difference will produce a photon of frequency nu or energy H nu. The transition E2 to E1 is the random. The random means incoherent condition. So this spontaneous emission release one photon randomly, means not fixed with the time, or fulfill the condition of the incoherent. The atom decays from level 2 to level 1 through the emission of a photon with the energy h nu. It is completely a random process and could not be used in the laser action. In the stimulated emission, E1 and E2 are the ground state and the excited energy state. The excited atom, when becomes de-excited by releasing the pair of the photon of the same frequency, same phase, same direction, and fixed with respect to the time, condition of coherent fulfill. Atoms in an upper energy level can be triggered or stimulated or induced in phase by an incoming photon of a specific energy. So stimulated emission is very useful to fulfill the condition of the laser. Now, the stimulated photons have unique properties in phase with the incident photon, same wavelength as the incident photon, and travel in the same direction as incident photon. If we see about the types of the laser, there are various types of the laser according to their source, according to their nature of emission, according to their wavelength, according to different levels, according to mode of pumping. If you see one by one, the gas laser, crystal laser, semiconductor laser, liquid laser are the under categories of the sources. In accordance to the nature of the emission, the continuous wave and the pulse nature, the pulse nature laser is the known as ruby laser, and continuous wave is known as helium neon laser. These are the basics of the laser which produce the pulse laser and the continuous wave. According to their wavelength, they have visible region, infrared region, ultraviolet region, microwave region, and X-ray region. According to different levels, 2 level, 3 level, and 4 level. According to the mode of pumping, optical, chemical, electrical, and electrical discharge. So these are the different types of the laser which are distributed in terms of the sources, emission, wavelength, different levels, and the pumping. Now, it is very interesting phenomena how a laser works. These are the components of the ruby laser. This is the first laser discovered by 1960 by the Professor T.H. Memon. You see, this is the power supply, this is the switch and the polished aluminum, and this is the part very important known as ruby crystal, and this placed in the quartz flash lamp tube, and the mirrors are 100% reflected in the one end while partially reflected in the other end. So the polished aluminum reflecting mirror, 95% reflecting mirror, and the laser beam produced in that direction. So these are the basic components of the ruby laser. Now the general procedure of the laser, the half reflected mirror and the fully reflected mirror, the distance between two is known as optical resonator. So optical resonator is the distance between two mirrors which are pasted on the end of the gain medium. The condition is that one is known as half reflected and other is known fully reflected. Why other reflected? The partially reflected mirror produce the laser output beam, and this optical resonator is the distance between the two optical mirrors. The distance between two optical mirrors is known as optical resonator. So this is the heating process or known as pump energy source in the gain medium for the required transition level. So gain medium is required, pumping energy source required, and optical resonator required for fulfill the laser condition. Basic principle needed for the laser. Now, the basic principle of the needed lasers are population inversion. So first of all, we will discuss about the population inversion, what to understand by the population inversion, and why the population inversion is necessary for the laser action. The question is that before the absorption, we know very well about the number of the atoms about N1 and N2 residing in the number energy state E1 and E2. Suppose there are N1 number of the atoms residing in the ground state energy level E1 and N2 are the number of the atoms in the upper energy state E2. So generally before the absorption process, it is known that the N1 is greater than N2. But for the stimulated emission, the population inversion is required for the direct or the continuous process. So the condition in which N2 is greater than N1 means number of the atoms in the upper energy state more and more in comparison to the lower energy level, then the condition is known as population inversion, means population invert. A state of a medium where a higher lying electronic level has a higher population than a lower lying level means N2 is greater than N1 is all known as population inversion. If you see the diagram, this is the 3 energy level diagram. This part is known as ground state and this part is the upper energy state excited energy atom, and the middle part is known as metastable state. The excited energy state is have the time 10 to the power minus 7 to 10 to the power minus 8 second, and the lifetime of the 10 to the power minus 3 second of the metastable state. Now question is that why the metastable is necessary for producing the laser action? It is very important question. So you see the lifetime of the metastable is more and more in comparison to the lifetime of the 10 to the power minus 7 second in the energy state. The condition is that when the atom interacted with the photon in the ground state, the atom becomes excited and goes to the upper energy level known as excited state. After passing the time of 10 to the power minus 8 second, it comes back to the metastable state and residing here for the more and more times in comparison to the higher energy state or the excited energy state. The metastable state required because the time delay is very important to produce the phenomena of the population inversion between the metastable state and the ground state. And during the stimulated emission of the process, the pair of the photon release and the continuous wave form of the laser light is produced. So metastable state play very important role for the continuous process of laser light production. So it is very important. You see, it is the very important question why we need metastable state. We have already discussed. Answer is with having the metastable state, above the ground level atom reaches the metastable state after first stimulated emission can remain there for longer time period. Therefore, longer time period, so the number of the atoms increases in the metastable state, and when these atoms come back to the original ground level, it emits laser beam. So the continuity of the laser beam is required or the essential part of the metastable state because due to the long lifetime in comparison to the excited energy level. If you see about the pumping, there are various types of pumping. What is the pumping? The method particle of raising a particle from lower energy state to the higher energy state is called pumping. There are different types of the pumping and different types of the pumping used in the different types of the laser. So first is known as optical pumping, electrical pumping, X-ray pumping, and chemical pumping. All the students keep in mind in the Ruby laser, optical pumping is the required according to a syllabus. So it is very important. If you see about the atom and photon interaction, at the high voltage, electricity causes the quartz flash tube to emit an intense burst of light, exciting some of chromium in the ruby crystal to the higher energy levels. At a specific energy level, some chromium ion emits photon. At the first, the photons are emitted in all directions. Photons from the chromium stimulated emission of photons from other chromium ions, and the light intensity is rapidly amplified. So mirrors at each end reflect the photons back and forth, continuing this process of stimulated emission and amplification. You keep in mind, mirrors are very, very important. Optical resonance phenomena is very important for the stimulated emission and which is very useful for the amplification. And finally, the photon leaves through the partially silvered mirror at one end. This is laser light. So there are two types of the level system, different type of the level system. We have already discussed about the 2 level, 3 level, and 4 level. The 2 level laser system, unimaginable. You know, unimaginable as absorption and stimulated process neutralize one another. The material becomes transparent. So we have required minimum 3 level laser system. So in this scenario, 2 level laser system is not possible, unimaginary. So minimum energy level is known as 3 energy level system. In the 3 energy level system, the condition is that one is known as ground state, other is known as highly excited state, and below, just below higher excited level is known as metastable laser. The excitation process between the ground state and the higher excited state, and the excited atoms de-excite in the metastable level, and population inversion is achieved metastable state and the ground state, and this transition is known as laser transition, and the population inversion is the cause of the stimulated emission of the radiation, and finally the output laser beam, continuously outer laser beam discussed. So initially excited to a short-lived higher energy state, then quickly decay to the intermediate metastable state, population inversion created between the lower ground state and the higher energy metastable state. It is a very important question. What to understand by the metastable state? The metastable state which is exist in between ground level and the excited level and have a long time for the de-excitation process is known as metastable state. Metastable state very necessary for the laser action because atoms remains in this state for a longer time, which is the cause of the stimulated emission or the population inversion and produce the continuous laser beam in the form of output laser beam. So this is the 3 laser system. If there are the tau 3, tau 2, tau 1, and tau 2, this is the time period between the 2 energy levels. Suppose this is the 1 energy level known as ground state energy level, and 3 is known as excited energy level, and the metastable energy state is the 2. So laser transition in between 2 to 1, and pumping required 1 to 3. The optical pumping phenomena is very important in the laser. So in the ND-YAG laser, the wavelength lambda is equal to 1.06 micrometer and the relaxation time 23 into 10 to the power minus 4 seconds. And if you see about the helium neon laser, the lambda 1 is 3.39 micrometer and the lambda 2 is 0.6328 micrometer and lambda 3 is known as 1.15 micrometer. And the relaxation time for the 2 level and the 1 level is 100 nanoseconds and 10 nanoseconds respectively. If you see about the 4 level laser, in the 4 level laser, the laser transition takes place the third and second excited state, rapid depollution of laser level. This is the 4 level laser. In the laser construction, the pumping source required gain medium and mirrors in the form of optical laser. These are the laser construction, pumping source, gain medium, optical resonator, and laser types. According to the active material, solid state laser, liquid laser, gas, excimer, and semiconductor laser. According to the wavelength, infrared, visible, ultraviolet, and X-ray laser. If you see about the solid state laser, the ruby laser is the most important example of the solid state laser, which produce the 694.3 nanometer output level. In the liquid laser, dye laser is very important. In the gas laser, is it known as helium neon laser, and in the helium neon laser, helium and neon, the ratio and the 10:1 and the operating system. This is the helium neon laser for the 3 energy level, 4 energy level system, which produce the continuously wavelength of the light. If you see different types of the emission of the wavelengths of the common lasers, so these are the laser types according to their wavelength. If you see argon fluoride in the ultraviolet region, it has the wavelength 193, and ruby laser and Nd:YAG laser 1064, and the carbon dioxide laser is known as wavelength of 10600. This is the typical laser types of their different types of the wavelength in the nanometer. If you see about the application of the laser, very interesting phenomena. The laser are used in the scientific field known as spectroscopy, lunar laser ranging, photochemistry, laser cooling, and nuclear fusion. In the form of the military, the laser rays are also known as death ray, defensive applications, strategic defense initiative, laser light, illuminator, rangefinder, and target designator. In the form of medical, this is the human eye. The eye surgery play very important role in the field of the laser. The laser, with the help of the laser, the eye surgery is 100% secure in comparison to the manual surgery. So laser is also known as in the field of the cosmetic surgery. In the application of the laser, laser are variously used in the industry and commercial, in the cutting, welding, marking, and CD player and DVD player, and laser printers, laser pointers, photolithography, laser light display. Not to be taken lightly. If you see the slide, the laser is in the form of nuclear fusion, long distance measurement, holography, and the application of laser technology in the field of medical, optical surgery, general surgery, tattoo removal, entertainment field, CD player, DVD player, and video game system in the form of telecommunication, information technology, holograms, satellites, and in defense in the military sector, the laser known as in the form of the weapons, radar, and industry. So nuclear guided missile and nuclear with the help of the laser can travel through a large distance. So this is the very, very vast discovery in the field of the. If you see the last slide, the laser everywhere in your life, you can use laser printer in our daily life and laser pointer during the time of the presentation. And this is the figure for the cosmetic surgery. So laser used every day in the life in the field of the barcode scanner, laser printer, laser pointer, and cosmetic discovery. So these are the references. Thank you.